Hi, AP Calculus students. Welcome to section 4.4b. This is on the mean value theorem of integrals, right? You already have a mean value theorem for derivatives, right? So this is the mean value theorem of integrals, the MVTI, right? This is usually referred to as the average value of a function. It's normally how they refer to it on the AP exam as the average value of a function, but sometimes you'll see it as the mean value theorem. They actually are the same, but the important thing is that in the real world, the average value of a function, so notice that's a y value, a value of a function, that the average value is very useful. And so you will see problems on the AP exam where they give you a function in a story and it says maybe the function is a velocity. And then they say, what's the average value of the velocity? And that is an indication to you to use this formula here. As soon as you see average value of a function, 1 over b minus a times the integral from a to b of f of x dx, and that equals f of c, the average value of a function. So let's talk about this more and see why it makes sense and what it means, okay? Excuse me. So number one, the mean value theorem of integrals, MVTI, is this. It's kind of what you already know, it just hasn't been said in this way. The integral from a to b of f of x dx, which you've seen quite a bit now, you actually know how to do this. Not only is it equal to capital F of b minus capital F of a, but take a look and see what else it's equal to. It is equal to b minus a, so the length of this interval, times f of c is a y value. So it is also really, this is a base of a rectangle and this is a height, right? So this is the area of a rectangle, right? And we knew that we know how to, when we have been given an a and b of a function, and its integral is the area between that function and the x-axis. And we're saying that this area equals this area here. Okay, so this is the area between the function, the x-axis on AB. This is the area of a rectangle where f of c is the height and b minus a is the width. As you can see, it really is the width here. Excuse me. So what happens then? This is the mean value theorem of integrals. But the way it's most useful is if we simply divide both sides of this equal expression by b minus a, right? So that would eliminate it on the right, and I would have 1 over b minus a on the left. So when we divide both sides by b minus a, here's what we get. The most useful form of the mean value theorem of integrals. The average value of a function is 1 over b minus a times the integral from a to b of f of x dx equals f of c, right? Obviously, when we divide it. Now, what does this mean then? This says that this is the average value, the average function value, which is a y value, or the height of the rectangle. So the AP or the text usually also wants the x equals c where it happens. So not only do they want the average height of that rectangle, the average y value, the average y of the function, but they also want to know the x where that happens. And so you just have to go one step further and take this y value, set it equal to the original function and find that x. But I also want you to see why this makes sense, like what is going on here. Here's what's going on. Why graphically? I drew an area here. Here's a function, f of x. Right here, I made it this nice curve, okay, on an interval from a to b, and here's the area, okay? If this were a rate function, like how fast you're going, right, from A to B, this area would represent how far you went, okay? Notice that if I made a rectangle from A to B below f of x, so let's say I made it right here, right? Every value of this constant function that I made right here, right, here's the area, is underneath that function. So obviously the area of this rectangle that has the dots in it is not equal to the area of the function, right? It's less than that because that f of c, right, that average y value right there is obviously less than f of x, right? So this is not the f of c here that gets the area that is equal to what I see. Let's go above it. What if my f of c from A to B were up here, right? My y equals something, right? What if this were my f of c, right? And I, from A to B, I drew the area, right? Obviously, because f of c is always above f of x, this area with the waves is much bigger than the area under f of x between A and B. But this tells us then that somewhere in between, if I move my f of c, my y value, somewhere in between this lower horizontal line and this upper, shouldn't there be a place where I can make a height of a rectangle on A to B that equals the area under f of x? It's got to be, right? And so what they want to know is right here, what is the f of c that makes a rectangle that has an area on A to B that has an area equal to the area under f of x? And they want to know at what x does that happen? Because of course it has to happen on the function at that x, right? When this horizontal value was below f of x, it didn't hit it anywhere. When this f of c value was above f of x, it didn't hit the function anywhere, right? But of course, somewhere in between here, there is a horizontal line I can draw, an f of c, that makes the area of a rectangle equal to the area underneath the function, and it has to hit the function, right? If it's always below it, the area is too small. If it's always above it, the area is too big. So it really does make sense, okay? How else does this make sense? Why logically? Let's say you are on a 3-hour trip and you have variable speeds, of course, right? You're speeding up, slowing down, start at 0, end at 0, and all that. But at the end, you see that you went 150 miles total, right? Can't you tell me your average speed, the average value, right, during your trip? Sure enough, if you went 150 miles for 3 hours, your average speed was 50 miles an hour, right? Because if you had constantly traveled at 50 miles per hour, you, for the 3 hours, you would have gone the same distance. Distance is area, right? You would have had the same area. And didn't there have to be a time, probably more than once, when you were going exactly 50? If your speed was variable and you were under 50, the only way to get the average to be 50 is if at some point you were over a speed of 50, meaning that's a continuous function. You had to hit 50 miles an hour at exactly one place. So it all makes sense, okay? Now, we're going to do the examples on the right about how you actually do this. So I'm just going to move you in a little bit. Oh, there goes my power a little bit, just so you can see a little bit better. We're going to do the example that you see here, and we're also going to do number 46 and 56. Whoops, I put it over here. Here we go. All right, so how do you do this? You don't have to draw a picture, but let's go with number 1. Find the average value of f of c and c, the x where it happens, of the integral from 1 to 3 of x cubed dx. So notice I tried to draw us a picture right here, right? So Now, when they ask us for the average value, we immediately write our formula, 1 over b minus a times the integral from a to b of f of x dx. Okay, so b minus a, right, is 3 minus 1, right, from 1 to 3 of x cubed dx. Okay, let's bring that 1/2 along. The integration of x cubed is x to the 4th over 4. And we're going to evaluate that from 1 to 3. Okay, so let's see. This is actually x to the 4th over 8 from 1 to 3. When we put the 3 in, that's 81/8 minus, when we put the 1 in, that's 1/8, and we get 80/8, which is 10. Okay, what does this mean? This means that f of c equals 10. This means if I drew, excuse my drawing, but if I drew a horizontal line at 10, I'm gonna go right across here, right? But only, struggling. Anyway, so, but only from 1 to 3, right? Take a look here. Is it possible, except for my drawing, that the area underneath this rectangle equals this area that we see shaded? Well, without a doubt, they both have this area in common, this purple area, meaning can I fit this area in there? Is it equal? Quite possibly so, except for my drawing, right? So now they do want the x where that happens. So what do? I'm going to erase a little bit. I'm going to keep that is y equals 10 right there. So they want to know the x where that happens. I mean, they want this point. They want that x right there. Where does that happen? So the next thing we do is we just take the function and set it equal to 10 and find the x where that happens. And that happens at the cube root of 10, which is 2 point something, which we can see. And we have answered their questions. Okay, let's try number 46 in the book. Get rid of that. There we go. On number 46, let's see. In black, in bold above, it says, find the values of C guaranteed by the mean value theorem for integrals for the function over the given interval. Mean value theorem of integrals does mean the average value of the function. And on 46, so I'll just write out our formula. There we go. That equals f of c. They are asking us for, we need to find this f of c, this average y value. And then we need to set it equal to the function and find the x where it happens. So on number 46, what they gave us is 9 over x cubed. If you don't mind, I'm just going to call that 9x to the negative 3, because when I integrate, I need to see that power from 1 to 3. Okay, here's my a, here's my b. So that is 1 over 3 minus 1. Obviously, you can just write 2, but I don't want to lose anybody. From 1 to 3 of 9x to the negative 3 dx. All right, we know how to integrate. Let's add 1 to the exponent and divide by the new exponent. Oh, not the x, just the exponent. There we go. So we have 1/2 times, this is 9 over negative 2. And this is x to the negative 2, so x squared from 1 to 3. All right, I'm just recognizing this here as, I could rewrite it, but negative 9/4, but we're okay. F of b minus f of a, f of b. When I put a 3 in here, 3 squared is 9, so these 9s cancel, and I have a negative 1/4 for my f of b minus my f of a. When I put a 1 in here, I'm going to get a negative 9/4. And that was being subtracted. So we're going to add that up. 9/4 minus 1/4 is 8/4 is 2. That is my f of c. Okay. So, and they want to know at what x does that happen? Where's my function? My original function is right here. 9 over x cubed equals 2. Let's say I'll multiply both sides by x cubed, right? There we go. I multiply both sides by x cubed. Divide both sides by 2. And take the cube root. And I get x will hit this average value of 2 will hit the function 9 over x cubed at the cube root of 9/2, right? And you can definitely turn that into a decimal. Okay. So really just, once you have the formula, really just doing the things that you need to do. Understanding in the back of your mind that you could always draw areas of the original integral and actually draw that f of c and see if the area underneath that rectangle really does equal the area that you drew when you wrote the integral. Number 56, they ask the same question, okay? So they are asking for the average value of the function and they want f of c and the x where that happens. So again, here's our formula for the average value of a function, right? And they give us that f of x. Of course, I picked trig, right? Because you just always need some help with that. Cosine of x, and that's from 0 to pi over 2. Certainly, I could draw a picture of that to remind myself of what's actually going on here. Okay, here's my a and here's my b. So b, 1 over b minus a is 1 over pi over 2. For the integral from 0 to pi over 2 of cosine of x dx. That is equal to, I'm going to take the reciprocal, 2 over pi. That happens a lot. The integral of cosine is sine from 0 to pi over 2, right? Because if I take the derivative of sine, I get cosine. F of b, sine of pi over 2 is 1 times 2 pi. There's my f of b minus f of a when sine of 0 is 0. So I have 2 over pi, which is, a little less than 2/3, right? So this is my f of c. Okay, how do I get the c? I set 2 over pi equal to the original function cosine of x, and they want the x where that happens. Well, I could actually answer x if this said pi over 6, right, equals cosine of x. I know, I guess if it was like 1/2. Like if it said 1/2 equals cosine of x, I know how to find the angle where that happens. This value of cosine is not apparent to me because it's not on the unit circle. They don't say this on number 56, and they really should have. You need your calculator to do it, right? So cosine of x equals 2 over pi, meaning I'm trying to find the angle where cosine would be 2 over pi. So that is an inverse, right? Remember that when you're looking for the angle, inverse cosine of 2 over pi equals, and when you throw that in the calculator in radian mode, you get about a 0.881, I believe. In fact, let me check. I think I just had it on there somewhere. I was doing a lot of work. I'm right. There we go. There you go. So very important theorem. Have a great day.